At the moment in this topology, switch 2 is the root. And we can prove that by using show spanning tree. And notice the local switch is the root for VLAN 1 in the topology. No other VLANs have been enabled. So the only Ethernet VLAN existing at the moment is VLAN 1, and all ports are in VLAN 1 on all the switches. When looking at the BPDUs, we can see that the switch is advertising a root path cost of 0, and the bridge ID and root identifier are the same. On switch 1, when we capture traffic here, it's advertising a root path cost of 4, and you can see that the bridge identifier is different to the root identifier. So on switch 1, let's change the spanning tree VLAN 1 root. So I'll change the switch to become the root, and in this case it'll be the primary root. That'll drop the priority of the switch. Previously the switch was using a default priority, which we can see in the Wireshark capture. It was 32768 plus the VLAN number. But now show spanning tree shows us that the switch priority has been reduced to a value lower than any current root bridge. So the switch has now become the root of the spanning tree topology. Bridge MAC address and root MAC address is the same. So there's our first Wireshark capture. And if I scroll down to the latest advertisements, notice the root path cost is 0, bridge ID and root identifier are the same, the priorities have been reduced. So this switch is the root with a lower priority. You can see that the bridge priority is 24576, extended system ID is 1, because this is VLAN 1, and the MAC address of the switch is set to the following. So once again, if we look through the Wireshark capture, this is capture 114 at the moment. Previously, the root identifier and bridge identifier were different. Now what about switch 2? Previously, this switch was the root. So notice on capture 1, this switch previously had a root path cost of 0, but scrolling down through the captures, you can now see that it has a root path cost of 4. Its local bridge identifier has a higher priority. So this switch is no longer the spanning tree root. Previously on switch 3, this was the root port. So here's the output. You can see that gigabit 00 was the root port on switch 3. What is it now? So show spanning tree. Notice gigabit 01 is the root port at the moment. So previously on switch 3, this was the root port, but the root port is now changed to this port because this switch is now the spanning tree root. The path cost using this link is 4, whereas now the path cost using this link would be 4 plus 4, in other words 8, to get to the root bridge. Spanning tree topologies can dynamically change. So as an example, if on switch 3 I shut down gigabit 01 and typed show spanning tree, what we can see now is that gigabit 00 is now the root port, as this port is no longer available. If I no shut that interface and type show spanning tree, you can see the interface is coming up. What you can see now is that gigabit 01 has become the root port once again, whereas this port is now blocking to stop a spanning tree loop.